Hello, welcome back. In this segment we're going to look at repetition structures in the C language. There are three of them: the while loop, the do while loop, and the for loop. Using the debugger is very important when you're learning how loops function, so we'll put a focus on that right from the beginning. When you're writing your loops, walk through them in the debugger so that you can actually see what they're doing instead of what you think they're doing. So all of the constructs for repetition are covered in this segment, and there's just those three: the while loop, the do while loop, and the for loop. So we've talked about sequence and selection in previous segments. The sequence of statements is just executing them from top to bottom one by one, and selection or selective execution of statements is using if else or switch. And in this segment we're going to look at how to express repetition. And repetition, you might guess, means to repeat some lines of code over and over while a condition remains true. And the first repetition construct we'll look at is the while loop. So here's the general form of the while loop. The keyword is while, and the condition will evaluate to true or false. So you can make a relational expression there, or anything that evaluates to true or false, and it should eventually become false, which means the loop will eventually end, or the repetition will eventually end. The rule concerning the parentheses is the same for the loops as it is with the if statements. The while loop controls one statement or one compound statement. So for the while loop, the braces will almost always be there. Okay, so here's an example of a while loop. We have the condition count is less than or equal to 5. So we have a variable count, and we have the stop condition for the repetition, and we have the compound statement which will be executed over and over. And when you just look at a piece of code that has repetition in it, it's almost impossible to know what it's really doing. So what you should do is walk through the code as if you were the machine. Start by writing down the names of the variables. We have only one variable. And write down output. And now as we execute this code, we will point at the line of code that's about to be executed. And we'll keep track over here in this table what's going on with the variables and the output from the program. So when we execute this line that the arrow is pointing at, the variable count becomes 1. Now we come to the while loop and we evaluate this condition. 1 is less than or equal to 5. Is that true or false? It's true, so the next statement is inside the loop, and we're going to execute this output statement where we'll output the value in count. So we're going to output count has count, and when we execute that, we're going to write down under output count has 1. So we're doing this with a pencil, presumably, to keep track of everything that the program is doing. So we'll move our finger down here to look at this statement. Count gets count plus 1. I suppose I should have used the increment operator that we learned in the last segment and wrote count plus plus. When we execute this, the count variable becomes 2, and when we come to the bottom of a loop, we always go back up to the top and evaluate the condition. So here we are, count is less than or equal to 5. Use the current value in the count variable. 2 is less than or equal to 5, and that's true. So we're going into the loop again, and we're going to output count has 2, and then we're going to increment the variable count. It becomes 3, and we evaluate the condition again. 3 is less than or equal to 5. That's true. So as we walk through it, we write down everything that the program outputs, and we write down every time a variable changes. 4 is less than or equal to 5. That's true. So go in and execute the loop. Increment the count to 5. Back up to the top. 5 is less than or equal to 5. True or false? Of course that's true, so we're going in to output count as 5, and then what will we do? Increment count to 6, go back up and evaluate the condition. The loop is not over until the condition has evaluated to false. When it does evaluate to false, like it does now, 6 is less than or equal to 5, then we will continue executing statements after the loop. So we fall out of the loop the first time that the condition is false. What I'd like to do is to take this little piece of code, the simplest possible while loop, and demonstrate how to walk through that in the debugger. So here we are in the development environment, and we have the same code that was on the slide, and walking through code on paper is okay when the code is not too complicated, or if you don't have an executing copy of it and you need to understand what it's doing. When you do have an executing copy of it, like we do here, this code outputs count has 1 through count has 5. What we would like to do is to ask the debugger to show us what this code is doing. So if you click out here in the gray margin, you'll get a big red dot, and that's called a breakpoint. When we click on the green arrow that says Start Debugging, what we will do is run up to that point. So we have a yellow arrow pointing now at the line of code which has not yet executed. And we have some new windows. We have a locals window down here. You might have to click on the locals tab to see the value of the current value of the variables. So we have a variable called count that has 1 in it, and we're about to evaluate that statement. You can say step over, which doesn't actually skip anything. It executes the line of code that the yellow arrow points at. So we were right, 1 is less than or equal to 5, evaluated to true because we're going in. We're going to execute the printf statement, and you can verify that that happened. So our program is running, it's just running very, very slow. And we can control each statement that we want to have execute. So click back in the development environment, and every time we click step over, it will execute that one line of code. So the variable count now has 2 in it, and we can watch everything that happens. We're going to evaluate 2 is less than or equal to 5, and that was true. So we went in and we're executing this code. Watch the variable count change, or you can hover over it and see the current value at any given time. So getting loops to work, you're not going to write the loops correctly the first time. You're going to write them and see what they do and then fix them. And the easiest way to see what they do is to walk through them in the debugger. And this one has done what we thought it would do, meaning when we walked through it on the slide, I don't have pencil and paper to do it with, but on the slide we pretended we were using pencil and paper, as opposed to this process of where we watched it actually execute in slow motion using the debugger. So here are some examples that you might want to work on. Output the multiples of 5 less than 100. Okay. Output even numbers in descending order from 70 to 50, inclusive. Sum the numbers from 1 to 100 and output the result. So making while loops that solve simple problems is the place to start when you're learning about repetition. When you make a loop, you need to know 3 things. Where do you start? Where do you stop? And how do you get there? So let's think about this first problem. Output the multiples of 5 less than 100. Where would we be starting? We would start with 5 and stop at less than 100. And how to get there? Well, multiples of 5 are 5, 10, 15, 20. So how we would get there is in steps of 5. So output the multiples of 5 less than 100. Let's go over to the development environment and solve that. The multiples of 5. We're going to start at 5. Where will we stop is the stop condition for the loop at less than 100. So while count is less than 100, we'll keep going. And how are we going to get there? Not in steps of 1 like we did before, but in steps of 5. And I'm going to shorten this to the compound assignment operator. Count plus gets 5. Is it correct? You're supposed to say, gee, I don't know. We should walk through it in the debugger and see if it's doing what we expect it to. Okay, output the multiples of 5 less than 100. So 5 is less than 100, that's true. So we're outputting the first multiple of 5, which is 5. Count plus gets 5. Add 5 to 5 and get 10. We're outputting count now is 15. Count is 20. So we seem to be outputting the multiples of 5. The only thing that we don't know now is if this program will stop in the right place. We want to be less than 100. If you have a loop that goes thousands of times, it's unlikely that you're going to step through it thousands of times just to see if it will stop in the right place. So there's a couple of things you can do. Set a breakpoint somewhere after the loop is over and say continue, which is the same button that we used to start the program. And now we've hit the breakpoint. So these are the multiples of 5 less than 100. We seem to have stopped in the right place. Another technique you can use is to make the problem smaller than the real problem actually is. Suppose the spec had said less than 20 instead of less than 100. Well, that one is much easier to walk through and see if it stops in the right place. We can walk through this loop and see if it stops while count is less than 20. And mostly I know this is quite easy for you, and I'm doing it as a demonstration of watching how the debugger works. So count is now 20. 20 is less than 20 is false. So I expect us not to step into the loop this time. And we didn't. So you exit the loop when the condition is false the first time. Back at the slides now. So I encourage you to go and solve these two problems that use a while loop. Output the even numbers in descending order from 70 to 50 inclusive. So 70, 68, 66 to 50. And then sum the numbers from 1 to 100 and output the result. There's a good example of where you might want to sum the numbers from 1 to 5 and output the result. And if you got that one right, then you can change it to 100 and see the result for the real spec will probably work if your smaller solution worked. Okay, we've already talked about counters and accumulators kind of as an aside, but a counter variable is an integer variable that will increase in steps of 1. So in this loop where we actually solve the problem of adding up the numbers from 1 to 100, we start out with a counter variable 1 and we add 1 to it up to less than or equal to 100. So a counter variable is different from an accumulator variable. An accumulator variable is each time through the loop accumulating something. In this case it's accumulating the count. So we have sum gets sum plus count. Each time we put the count into the accumulator, and each time we add 1 to the counter. So counter variables and accumulator variables are simply int variables, but they are serving different purposes. Well, accumulators might sometimes be of other data types. It's quite reasonable to have an accumulator of double values. I want us to talk about sentinel-controlled loops. In this case, you would be writing a loop where you don't really know how many times it's going to repeat. So a sentinel controlled loop might be looking for a particular value and as the condition for when the loop will stop. This is different from a counter-controlled loop, which uses a counter variable to decide when to stop. So consider this specification. Ask the user to enter test scores, and when they've entered all the scores, then they will enter the value -1. We want the program to sum up all of the scores entered and output the result. So how many test scores are going to be entered? We don't know, but we know that the value -1 will be an indicator that all of them have been entered already. And we'll write a sentinel controlled loop which looks for the sentinel value of -1. So here's the spec. Ask the user to enter test scores. When they've entered all the scores, then they'll enter -1. And the program will sum up all of the scores entered and output the sum. Okay, I'm in the development environment and I brought this spec with me. Ask the user to enter test scores, and when they've entered all the scores, they will enter the value -1. So this is a sentinel controlled while loop that we're going to write. First, let's make a place to score the test score, and let's make a place to hold the sum of the test scores and initialize that to 0. We don't need a counter this time because we're not making a counter-controlled loop, we're making a sentinel-controlled loop. So the first thing I'll do is I'll prompt the user to enter a test score, and then I'll scan in the test score. It's an integer. Don't forget the ampersand before the variable. And now I'm going to make the while loop. So I'm going to say while the score is not equal to the sentinel value, -1. And right at the end of the loop, I'm going to repeat these two lines. And my indentation is not correct, so I'm going to ask the development environment to fix it for me, selecting some code, edit, advanced, format selection. So now the indentation is correct. So here's the behavior of a sentinel controlled loop. We ask the user for the first value, and then we test it while the value entered is not equal to -1, and it's not, so we'll go and we'll process that value here. And then at the bottom of the loop, we'll ask them the same thing for the next value. The first thing we do with the next value entered is we go up and test it for the sentinel. If it is the sentinel, then we won't process it. If it isn't the sentinel, then we'll go in and process that data. For us in this spec, processing the data is quite simple. We're just going to add it to a sum. Sum plus gets score. So as usual, I'm going to put a breakpoint there, and we're going to run this code and see if it does what we expect it to do. Enter a test score. Well, let's be optimistic and enter 90. And, a bug. I've made a mistake here. And I want you to see how useful the debugger is. I entered the value 90 and I immediately see that I don't have the value 90 in my variable. Do you see the bug? Maybe you already saw it. Sometimes different eyes see different things. So I put an ampersand here instead of a %sign. So the amount of time it takes you to find the bugs is greatly reduced by using the debugger, and I'm really glad that that point got made here by me making that simple typing mistake. So there's a blue box up here that says stop debugging. I'm not interested in processing anymore. I want to go and stop this whole thing and fix my bug. %I, and now run again to the breakpoint. It will ask me to build, and I'll say yes. Enter a test score. Let's put 90, and that feels much better. 90 is not equal to -1. That's true. So we're going in. Sum plus gets score. Sum has 90 in it, and now we're prompting the user for the next value. And I have the same bug down here. Darn it. So I'm going to stop the whole thing, run again, Each time we run it, we'll get a little bit faster. Maybe there'll be fewer mistakes. Okay, we're going to say 90. 90 is not equal to minus 1. That's true. Sum now has 90 in it, asking the user for the next value. Let's put 100, even more optimistic. And score now has 100 in it. We go back up to the top. 100 is not equal to minus 1. So we have another piece of valid data, and we'll add that into the sum. So let's suppose that we don't have any more valid grades, and this time we're going to put minus 1 to indicate that we only had 2 grades. And the first thing we do with the minus 1, we go back up to the top and we test it. Minus 1 is not equal to minus 1. That's false, and the loop is over. So what is in our sum variable? It has the sum of all the grades entered, and it doesn't have minus 1 added in. That would be erroneous because minus 1 is not a piece of data. It's only a sentinel value. A sentinel meaning a guard or an indicator that all of the data has been entered. So here's the general format. It's called an idiom. It's just the way that people do things because it's easy. You ask for the first value before the loop starts. You test for not being the sentinel value, and then you ask for the next value at the bottom of the loop. There's something about this code that I really don't like. I probably should have told the user what the sentinel value was in the prompt. The user can't see the code, so they probably shouldn't have to guess that it was minus 1 that we were looking for. It could have been, the sentinel value could be any value. We just make up something that isn't a reasonable piece of data. So in this case, the score wouldn't be reasonably minus 1. Okay, let's consider the next repetition construct in C, and this is called the do-while loop. And I'll introduce the do-while loop by comparing it to a while loop, which is the one that we've already looked at. So a while loop, here's a while loop that counts to 3, not too complicated. And here's a do-while loop. Look at the syntax. The keyword do comes at the top, and while comes at the bottom along with the condition. So while count is less than or equal to 3. The do-while loop is a post-test loop. That means we check at the bottom and decide whether we're going to go back up to the top. Pretty much all modern languages have some form of a post-test loop. Contrast it to a pre-test loop where the condition is at the top and we decide whether we're going to go in to the body of the loop. A post-test loop, the do-while in C, has no way of stopping the loop body from happening the first time. So we go in and we do the loop, and then we test at the bottom whether to go back up to the top. The do-while loop is not favored very much in industry. It's a little bit confusing to test things at the bottom. There are cases where it's a good choice for your repetition construct, but not so much. So it might be difficult for you to look at these two and be able to say that they do exactly the same thing. I think it's because the do-while loop is just not how we think. We think more in the way that the while loop works, testing whether or not to do something and then do it, as opposed to doing something and then testing whether we should do it again. So there's the do-while loop. Probably we won't use it very much. Okay, so here's on this slide all of the things that I just said. It can be difficult to read and understand. Also, if you have a large loop body, you see the start of the loop and then you have to scroll down to the bottom to see the stop condition and then scroll back up to read what the body of the loop is. And it's really just very awkward to work with do-while loops. The last repetition construct in C is called a for loop. And the for loop is most commonly used when you're creating a counter-controlled loop. There isn't anything that a for loop could do that you couldn't do with a while loop, but it's easy to read. So you should be using for loops. This is the general form. The keyword is for, and then we have three expressions separated by two semicolons. This is a requirement. You must have two semicolons or it won't compile ever. So what are the three expressions that we're going to put in this one line of code? Remember when I said during the while loop discussion there are three things that control the behavior: the starting place, the stop condition, and how do you get there. So in this simple while loop that loops three times, starting at 1, less than or equal to 3 is the stop condition, and incrementing in steps of 1. Those are the three expressions that we're going to put in the for loop, and the behavior is the same as we have on the left. So the initializer expression happens only once, and then the Boolean expression, or the stop condition, happens each time at the top. So count is less than or equal to 3. If that's true, then we're going into the body of the loop. Expression 3 happens as if it were on its own line right here at the bottom. So at first it's a little bit complicated because there are three things on one line of code that don't happen all at one time. But once you get used to them, the for loop is much more convenient for counter-controlled loops in C. Let's go into the development environment and play with the for loop just a little bit. Okay, we're in the development environment, and I'm going to declare a count variable and initialize it to 1, and then I'm going to make a while loop and demonstrate that the for loop is the same as the while loop. It's just all written on one line. So if we say count is less than or equal to 3, we're making a very small loop that will iterate 3 times. And I try to encourage people to type the close brace at the same time they type the open brace, so you won't have to be trying to decide whether all of the braces are closed or not. Okay, there we have a printf statement that will just output the count, and let's make sure that we've done that correctly. Count is 4, so that's going to evaluate to false. And let's look at the output. Count is 1, count is 2, count is 3, so that seems to have worked. Now I'm going to make a for loop here which does exactly the same thing. So the for loop has 2 semicolons in it all the time or it won't compile. And here's the body of the loop. We can make this a fill in the blanks problem. So the first expression in the for loop is the initializer, and we'll put count gets 1, and then the second expression is the Boolean. We'll write count is less than or equal to 3, and then the third expression changes the control variable, and we'll write count plus plus. And I'll cheat a little bit and just take that line of code and paste it in here. So I'm going to run this without any breakpoints and just see that we do have the same behavior, and then I'll show you walking through the for loop in the breakpoint. So the first count 1, 2, 3 is the while loop, and the second one has the same behavior, it's the for loop. Now let's run to that breakpoint. Count is 4, which is left over from the previous loop. So if we step over, now count is 1, we've executed the Boolean condition 1 is less than or equal to 3, but we have not yet executed expression 3. So we're going to output that the count is 1, and now we're going to execute expression 3 next. So count plus plus, count became 2, and then we said 2 is less than or equal to 3. In the debugger it seems to show that that happens at the same time, but it doesn't. The expression 3 happens first, and then expression 2. I like to convince people that expression 3 happens as if it were on a line by itself down at the bottom of the for loop. The debugger doesn't show it that way, but it does give you the feeling of when expression 3 happens. And when we go back up to the top, we're not going to do expression 1 again. Setting the count back to 1 each time wouldn't make sense. So the yellow arrow is pointing here, but it's doing expression 3, then expression 2, and then we're going into the loop, if it's true. So count is now 3. This is our last time. So this time we're going to do count plus plus. Count will become 4. Then evaluate the condition. It will be false, and we fall out of the loop. So the reasons that the for loop is better than the while loop in some situations is because it's easier to express the 3 conditions that express the behavior of the loop: the start, the stop, and the how do you get there. Okay, we have pre-increment and post-increment, and we used post-increment here. What would be the difference if I had used pre-increment? There are a lot of C programmers out there who think that there is a difference, but there isn't. Remember, pre and post are before and after everything in that statement. Now pretend that expression 3 is on a line by itself down here at the bottom. There is nothing before or after in expression 3, so it just adds 1 to count, and it doesn't make any difference if it's pre or post. Most people use post now. I'm not really sure why. There was a time in C when almost everyone used a pre-increment in their for loops, and it genuinely doesn't make any difference. Well, we've now looked at all 3 of the control constructs in C: sequence, selection, and repetition. Repetition is the one that people find the most difficult, so you should practice with this. Walk through loops on paper and walk through loops in the debugger until you're comfortable with how they behave. Solving problems with repetition or with loops also takes a little bit of practice. Think about when you're solving a problem with a loop, where do you want to start, where do you want to stop, and how do you want to get there? And if you can express those 3 things, then you have the behavior of the loop. Try to express your loop separate from the rest of the problem. So you want to do something n times, you should think about making the loop construct that goes n times and then worry about what goes inside it. It takes a little bit of practice, and I can't do that for you. You have to be practicing. We looked at counter variables and accumulator variables, and we looked at using a test case for walking through your code and making sure that it does what you expect it to do. Pick a simple test case first. If your loop will not work for a simple case, it won't work for a complex one. So pick a simple test case, get your loop working for the smallest possible number of iterations, and then worry about getting it working correctly for the real specification that you have to work with. We looked at the 3 repetition constructs: the while loop, which is a pre-test loop, and the while loop is often used for making sentinel controlled loops, loops where you don't know how many times the loop is going to go until you see what data is entered. And the do while loop, which is sometimes called a post-test loop, because you decide down at the bottom of the loop whether or not to go back up to the top. These have to be used sparingly. I think people don't generally like them. People don't think this way. People think about whether to do something with the test at the top. So you decide whether you're going to do it and then you do it, as opposed to doing something and then decide whether to do it again. It's 2 different ways of thinking. Sometimes a post-test loop is the right way to do it, but those are fairly rare. And the for loop, which has the 3 expressions separated by semicolons, this for loop is very often used for counter-controlled loops, where you know how many times the loop will execute, or you know what variable will be tested to know when to stop the loop. And the for loop is very convenient once you get used to it, because on one line of code you specify the start, the stop, and how you get there. It makes it very easy for people to read the behavior of your repetition, and that's kind of the preferred one if you have a counter-controlled loop. Okay, in the next segment we're going to look at solving problems with these, and so understanding the mechanism of how a loop works is quite different from being able to solve a problem with a repetition structure. And that's what we're going to look at in the next segment. I'll see you then.